DART demonstrated that humankind is capable of redirecting an asteroid. The mission to Dimorphos and Didymos hit the smaller body and changed its orbit around the larger asteroid. Now, ESA's HERA will visit this asteroid pair to investigate how DART affected Dimorphos. HERA will gather the data we need to turn kinetic impact into a well-understood and repeatable technique on which all of us may rely one day. My thanks go to everyone who worked so hard for so long to make HERA possible. Best wishes for a successful start of this epic journey.
Launching HERA today is Falcon 9, a two-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. Starting at the top of the vehicle is the payload fairing, a protective shell that encases the payload being sent to space. That fairing will separate and jettison away from the vehicle, exposing the payload once Falcon 9 reaches space. And here you can see on your screen a photo of HERA being encapsulated in that fairing just a few days ago. The fairing halves that we are using today have supported multiple missions, one having flown 12 missions and the other 18. Now, continuing down the vehicle, we have the second stage. The second stage is powered by a single Merlin vacuum engine, or what we call the MVAC engine, which is optimized to perform in the vacuum of space. And below that is the first stage, which contains 8 engines arranged around one center engine held in place by a structure called the octaweb. Now, each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust. The booster supporting today's mission previously launched 22 missions, including Crew 1 and Crew 2, SXM-8, CRS-23, XP, Transporter 4 and 5, Global Star FM-15, ISS Aero C3, Korea 425, Maxar 1, ASBM, and 10 Starlink missions. Now, due to the additional performance required to deliver today's payload to an interplanetary transfer orbit, this will be the 23rd and final launch for this booster, and recovery is not planned. However, we will be recovering the fairing halves. So with that, let's check in with John I for a status update on today's launch.
The launch vehicle and spacecraft are in good health. They're ready for launch as we are just beyond T-minus 9 minutes to liftoff. The Falcon 9 team reported on console at T-minus 2 hours and 15 minutes. They began their final checks of the launch vehicle and ground systems. We did a final checkout of the flight termination system. That was at T-minus 1 hour and 45 minutes. We then had the Falcon 9 team complete their data review of first and second stage propellant checkouts, as well as the avionics team and the guidance, nav, and control team. And they did all their final data reviews at T-minus 1 hour. At that point, the chief engineer conducted a technical readiness poll, and everything was go to continue. We've also completed at T-minus 38 minutes the poll to proceed with propellant load and launch. And most recently, you might have heard over the countdown net, the spacecraft has gone on internal power at T-minus 18 minutes and 30 seconds. Now, currently, the team at Cape Canaveral Space Force Station, they are loading propellant. That began on time at T-minus 35 minutes when our launch auto sequence began. We're loading 2 propellants on Falcon 9 today, a fuel and an oxidizer. Now, for Falcon 9, our fuel is a refined form of kerosene known as RP1. To burn that fuel, we need a source of oxygen, which we call the oxidizer. Now, most burning that you're familiar with on Earth uses oxygen that makes up about 21% of the air you breathe. But in space, there's no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Now, Falcon 9's oxidizer is super chill liquid oxygen, what we call densified LOX. Now, the liquid oxygen is chilled well below its boiling point. That allows its density to be increased, and that in turn allows us to load more into the first and second stage LOX tanks. And that's an important advantage for missions like today's, where we need as much propellant as we can carry to get to the required interplanetary transfer orbit. Now, currently on the Falcon 9, you see on your screens, fuel loading is complete on the second stage. We're continuing on the first stage up until about T-minus 6 minutes when fuel loading will wrap up on that stage. And we are loading liquid oxygen onto both the first and second stages right now. In addition to its propellants, Falcon 9 also needs an ignition source to start burning that fuel and oxidizer. And for that, we use a liquid called T-Tab.
Stage 1, RP1 load is complete.
And there we're on time. Fuel load on the first stage is complete. I mentioned T-Tab. That's an acronym for a mouthful called triethyl aluminum and triethyl borane. Now, when we ignite the engines, we first flow liquid oxygen and T-Tab into the gas generator in the main combustion chambers. The T-Tab will burst into flames in the presence of the oxygen. So once we have that ignition, the RP1 kerosene fuel is introduced and the Merlin engine goes to full power. And at liftoff, Falcon 9's two stages that you can see next to the strongback, they will combine to hold over 1.1 million pounds of the fuel and oxidizer propellants. Now, to provide maximum performance for the HERA mission, Booster 1061 will use all of its propellant. We won't save any for the landing of the first stage. On the weather front, you can see on the screen, it's cloudy, it's been a little rainy. We started the day with a 50% probability of violating launch weather constraints. But the good news is that the weather officer forecasts that we should be go 5 minutes from now. Mostly we've been watching thick clouds, make sure they're not too cold, where you might have triggered lightning. The good news is the clouds are warm. Everything looks just pretty much gloomy, a little rainy.
Tanks are pressing
with
for
that,
strongback retract.
You hear the tanks are pressing. We're getting ready for strongback retract. So inside T-minus 5 minutes, all systems are go for launch from Space Launch Complex 40 in Florida. So Jesse, let's head back and watch the last of the countdown.
Thanks, John. It is T-minus 4 minutes and 38 seconds and counting. And as John mentioned, everything continues to look go for liftoff at T0. Now,
Strongback retract has started.
perfect timing. You heard that call out, that strongback retract has begun. Now what's going to happen here is the clamp arms, which are just below the fairing, are going to open up, and once those are fully open, then that strongback, or what we call the TE, or transporter erector, will begin to retract away from the vehicle. And you can see on your screen that those clamp arms are opening up there. Now, the TE is designed to transport, raise, and support Falcon 9 at the launch pad using umbilicals or flexible lines to route the vehicle's fluids, power, and telemetry from the ground systems to the rocket and the payload until Falcon 9 switches to internal power and clears the pad. And you can see the clamp arms are now fully open, and that strongback, there you can see it on your screen, the TE is now moving slowly away from the vehicle. Now this is going to recline just a few degrees here, but at T0 it's going to move even further away, about 45 degrees away from the vehicle as Falcon 9 lifts off. And there you can see that the TE is pretty much fully reclined there on your screen.
Coming up on T-minus 3 minutes. Strongback is in the countdown configuration. It's about 1.5 degrees away from the Falcon 9. Waiting for next is completion of liquid oxygen loading on the first
Stage
stage.
1 LOX load is complete.
Right on time. So at this point in the countdown, the first and second stages are nearly fully loaded with the 1.1 million pounds of fuel and liquid oxygen. We have loaded all of the fuel on first and second stage. Liquid oxygen is now complete on the first stage. The last major event will be T-minus 2 minutes when we finish loading liquid oxygen on the second stage. And you can see right there the cold, chilled skin of the second stage. There's the warm Florida air moving by it. We're seeing the condensation of the moisture in the air. Everything continuing to look good as we come up on T-minus 2 minutes.
Stage 2 LOX load is complete.
And there's that call out, that liquid oxygen loading is now complete on the second stage. Now that means that propellant loading is complete on Falcon 9, and that's over 1.1 million pounds of propellants now loaded on the vehicle. All systems remain go for launch. SpaceX ground computers are now draining propellant out of the lines that go up to the strong back onto the second stage. And there you can see that venting happening there on your screen. Now this creates a white cloud, which is pressure from the ultra-cold liquid oxygen line that's being vented there.
Front gas closeouts.
And again, when that cold liquid oxygen gas meets the warmer ambient air there, it creates that condensation that you can see there on your screen. Now, the first and second stage computers on Falcon 9 will execute stored programs to prepare the rocket for flight, leading to the ignition of the M1D engines at T-minus 2 seconds and liftoff at T-minus 0.
Falcon 9 is in startup.
With that call out, the Falcon computers are running the final sequence for launch. First and second stage tanks are beginning final pressurization for launch. All systems are go. Let's listen in to terminal count.
LD, go for launch.
As Falcon 9 transports the European Space Agency's HERA spacecraft into space.
Seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power. And liftoff. Go HERA, go Falcon, go SpaceX.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 40. After clearing the tower, we begin to tilt or gimbal the engines. That initiates a roll maneuver you might see on the Stage 1 camera view, although it's kind of cloudy. But this enables the vehicle's antennas to stay in the best position for communicating with the ground. We are into throttle down now in preparation for max dynamic aero.
Falcon is supersonic.
Faster than a speeding bullet, we're supersonic on Falcon 9. Waiting for the call out from GNC of Max Q.
Max Q.
Right on time, we're through the period of maximum pressure on the vehicle. The Merlin engines are back at power and we're out of the throttle bucket. Now from here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and that's resulting on less loads on the Falcon 9. 90 seconds into flight, the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth and getting into orbit. We've heard the call out for MVAC chill. That's a bleed valve on the second stage engine that's performing the final chill prior to second stage engine ignition. All's looking good with the first stage trajectory. We're coming up on T plus 2 minutes. Views from onboard the camera mounted on the inner stage of Booster 1061. Now we've got 3 events that'll be coming up in just under 30 seconds. Main engine cutoff, the 9 Merlin engines will be throttled down and shut down. Then we'll get stage separation and then startup of the MVAC engine on its first of 2 burns on the second stage. We've begun throttling down the Merlin engines.
Main engine cutoff.
Call for MECO.
Stage separation.
Successful stage separation.
MVAC ignition.
MVAC ignition and weapon power on stage 2. Coming up will be fairing deployment. And for the first stage, as we saw it in the background, farewell 1061, and we thank you. As we continue climbing out of Earth's atmosphere, we're waiting for the right time when we can open up and deploy the fairing. That should be coming up in about 10 seconds. There's a camera view as we switch. You can see HERA inside the two halves of the fairing.
Fairing separation.
And successful payload fairing separation. As we mentioned earlier, the fairing halves have supported multiple missions. One half has flown 12, now 13 missions, and the other had previously flown 18. And those fairing halves will come back down to Earth. They're guided by cold gas thrusters and then parachutes or parafoils.
Falcon is on a nominal trajectory.
They'll deploy and they'll be recovered by our recovery vessel, Doug. Jesse, T plus 4 minutes, 23 seconds. Everything continues to look good on Falcon 9 with HERA.
Thanks, John. Yeah, everything's looking great. We got some awesome views here on your screen. What you're looking at is a view of the MVAC engine on the second stage with a beautiful view of Earth in the background.
STS has safed.
Now, we are currently in the first of 2 planned MVAC burns for this spacecraft. And we have separated for the first stage from the first stage. As we mentioned earlier, we will not be recovering the booster as we usually do. Now, typically we would land the booster either on a drone ship or back on land, but due to the performance, the additional performance required to deliver this payload to an interplanetary transfer orbit, we will be not recovering the booster today. Now what you are seeing, again, is the MVAC engine. The MVAC engine is optimized for the vacuum of space and has about 220,000 pounds of thrust in vacuum. Again, this is the first of 2 burns. The 2 burns for the MVAC engine will take the second stage with the payload attached to the targeted drop-off orbit.
Falcon continues to follow a nominal trajectory.
And great call out there, following a nominal trajectory. You can also follow along with the speed of the vehicle as well as the altitude in the bottom right hand corner of the screen. And the next event coming up in about a minute and a half from now is SECO 1. SECO 1 is second stage engine cutoff 1, which is where we will shut down that MVAC engine and allow the vehicle to coast with the payload in an Earth orbit, and then we'll reignite that MVAC engine for a second time to take the vehicle and payload to that interplanetary transfer orbit. Now we're just about a minute away from SECO 1. And you can see in the bottom right hand of your screen that the speed is continuing to pick up. The velocity is increasing on the vehicle as the MVAC engine continues to burn. But again, in about 40 seconds from now.
Stage 2 is in terminal guidance.
In about 35 seconds from now, we will shut down that MVAC engine and again allow the vehicle to coast in an Earth orbit before we make its way to the interplanetary transfer orbit.
Stage 2, STS has safed.
Continuing to get good call-outs and some great views here. Again, this is from the second stage looking at the MVAC engine. The HERA payload is still attached.
MVAC shut down.
Nominal park orbit insertion.
And great news. We heard the call-outs as well as saw that MVAC engine shut down, and we got a good confirmation of nominal orbital insertion. Now, the second stage is now embarking on the first portion of its coast phase. Coasting in this orbit will last about 45 minutes, and we will light that MVAC engine for a second time around T plus 52 minutes. So we're going to take a pause, and we'll see you back here at T plus 52 minutes for SES-2.
Well, welcome back. If you're just joining us, that was an amazing launch that we've just witnessed. The Falcon 9 lifting off from Cape Canaveral, a cloudy Cape Canaveral. So taking the HERA mission on its way. I am grinning ear to ear. There's a lot of happiness and jumping around in this studio. We're trying to keep it down because people are working, but there was very tense emotions in mission control as well. We had a lot of tears, and outside in the public event, people were jumping around and spilling their beers. So the excitement is building here in the studio in mission control. Let's take a moment to check in with the atmosphere is electric. Everyone cheers. The rocket is carrying off into space. It's an incredible moment. I'm going to take you over now to the main control room. Andrea, before we go for that critical acquisition of signal, can you introduce some of the incredible team? I know that they're probably a little bit the emotions are running high, but
sure. Yeah, thanks, Matt. Yeah, indeed, it was quite a moment here. The spacecraft is gone. But let's introduce a couple of people here in the control room. I have Richie next to me. Is one of our system engineers. Richie, it's been a while. You haven't been here in the temple of mission control. What's the feeling today?
I'm feeling quite overcome with emotion at the moment. It's been 10 years since I was here with Rosetta when we landed on a comet. It's been a long time working in mission development since then, so it's good to be back. Exciting to see the launch, and I'm just excited to get on with operating the spacecraft.
Excellent. Get ready for the rest, and the best is to come. So I moved back here to Spacecraft Operations Manager Sylvain Lodiot. Sylvain, here we go. You wanted actually to move on to this mission after we finished Rosetta. Am I right in saying that this is a dream coming true finally?
Yes, it's correct. I mean, it was very difficult to say goodbye to Rosetta. There was then 4 amazing years on Solar Orbiter with an amazing team, very challenging. And now it's time to fly HERA. So it's also been very intense and amazing years with another amazing team. So it's time to fly, and many emotions today.
Yeah, I can imagine. Same for me. I moved further backwards here to Gabriela Ravera. She's one of the most experienced people in the room here. Gabriela, we have done supported several critical operations here from this room. What was special for this mission or for you?
Okay. Shall I?
Please.
So basically, I mean, what makes it special for me is that you are not sitting next to us this time. So that's the first thing, of course. But talking to HERA in particular, it's the first time for me that I do a first acquisition with a non-S-track station and with DSN in particular. So that's a big challenge for us because it means that we will be communicating for HERA for the first time ever via our colleagues in DSN. We trust them a lot. We have been rehearsing and testing since almost a year now, which makes this moment very, 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 very special. Also, if we are in the blind.
Good, thanks, Gabriel. Indeed, very important to underline this collaboration we have with the colleagues across the Atlantic. And this is all from the MCR. Back over to you, Matt.
Thank you, Andrea. I don't think there's anything more iconic as Andrea's smile. Good luck to all the incredible team in Mission Control as well as we await the all-important acquisition of signal. Wow, what an amazing day. As we continue our special coverage, I'm more than excited to introduce our next guest. It's Matthias Maurer, a European Space Agency astronaut who returned in 2022 from his Cosmic Kiss mission aboard the International Space Station. In fact, he rode on the exact same launch vehicle as we've just seen here at launch there. So, Matthias, it's an absolute honor to have you on the show. Welcome.
Well, thank you. The honor is all mine, and congratulations to the launch team. That was a fabulous launch.
Well, it was, wasn't it? Very exciting. Yeah. So obviously this is all about asteroids and planetary defense. So what significance do asteroids pose to people on the International Space Station and space exploration in general?
Well, the day the International Space Station would have an encounter with an asteroid would be a really bad day. But we astronauts, we also hope to fly further than the International Space Station. The next step will be the moon. And on the moon, we have lots of impact craters. And that's why we all also get training. And we go, for example, to the Nördlinger Ries, which is a massive impact crater here in Germany, where an object the size of 1 kilometer in diameter, so a tiny little bit larger than the object we're flying to right now, hit Earth 15 million years ago and left a massive crater of 25 kilometers in diameter. So this we don't want to see happen again, and that's why we fly this mission.
Yeah, so do you see human missions to astronauts contributing to the understanding of how what we do to try and protect the planet?
Yes, definitely. So I think a mission like the one that we see today, HERA, that is better done by a robotic mission because it flies out 2 years and there's a lot of radiation that an astronaut would get on such a mission out there. And it's a one-way mission. I don't want to fly a one-way mission.
Don't blame you.
Yeah. But I believe in the future we will learn so much, and already in 29 we will have another asteroid flying very close by of planet Earth, so around 40,000 kilometers, so actually much closer than the moon. And this could be in reach of even a human mission if we are ready by that time. But I don't think we will have the technology in 29. But let's think a little bit beyond the horizon. Such an asteroid may pose a threat to humanity once it impacts, but some of these asteroids actually are very precious. They contain a metal core of like maybe even very precious metals, like the asteroid Psyche. And so I could well imagine somewhere in the future we will actually deflect such an asteroid to bring it closer to us so that we can mine it.
Yeah, so I mean, obviously it's very, very hard to get out to an asteroid, as you just explained. So would there be a real reason to send a human to do it rather than a robot?
Well, I think for the moment being not. So maybe you can send Bruce Willis. He already demonstrated his success in saving planet Earth. Yeah. But maybe in the future we will, I believe step one is we need to learn how to deflect such an asteroid, to deflect, to understand how such asteroids are built up. Just to get the basics ongoing, and maybe in the future we will have other purposes of flying to an asteroid.
Yeah, do you have a favourite asteroid? You mentioned Psyche earlier on.
Yeah, the Psyche one, it's like, I'm a material scientist, so I think flying to Psyche and getting the precious metal ore out, that could be also another childhood dream.
Yeah, it would be amazing. Do you have a favourite asteroid mission?
Well, I believe that one, HERA, is absolutely fantastic. I cross my fingers that we will see all the good scientific results flowing back, but also the mission following after, the one that probably the Ramses mission that we all talk about, to fly in 29, to visit the asteroid that will fly by Earth in such a close distance. That will also be another step.
Yeah, so we've just seen HERA sat on top of a Falcon 9 and go through the exact same journey that you went through. So if HERA suddenly became conscious like a Greek goddess, explain how that would have felt.
Well, I mean, it's like I wouldn't recommend HERA to go conscious. I think it should stay alert and awake and going straight on. But in our mission, we had a commander, and the commander had also like a lever to pull on in case something goes off nominal. So we could have ejected from the rocket and then have safely landed back on planet Earth. I think HERA doesn't have this option. No. Also, our booster landed back on planet Earth. Here we needed all the fuel, all the last drop of acceleration to bring HERA on a good mission to the encounter with the asteroids.
Yeah, so that booster's lost forever now.
I think it made a good history. It's an honourable end.
It's an honourable end for a booster indeed. Matthias, it's been an absolute genuine thrill to meet you and have you give us your special twist on the HERA mission. Thank you very much.
Thank you.
So, if you've just joined us, we're broadcasting from Europe's Spacecraft Operations Centre here in Darmstadt, Germany. We're following the launch of ESA's HERA mission, a planetary defence spacecraft. Today marks the beginning of an exciting mission to explore the Didymos asteroid system. Stay with us, we'll guide you through separation. Here's first call from space. While HERA makes its way towards separation, it's a perfect time to dive deeper into the topic of planetary defence, which is at the heart of this mission. So I'm delighted to be joined, I don't know what happened there, to be joined by two special guests who I've rushed on and rushed off poor old Matthias. I'm sorry. So I've got delighted to be joined by Romana Kofler, Programme Manager Officer at the United Nations for Outer Space Affairs, and Richard Moisel, Head of the Planetary Office here at ESA. Together, they'll help us explore the global efforts to protect Earth from asteroid threats and the importance of the collaboration in planetary defence. Welcome to you both. So, Romana, first question to you. Planetary defence is a critical issue when it comes to asteroids especially. What are the main risks that we face from near-Earth objects, and how are these risks evaluated and monitored?
First of all, congratulations on the successful HERA launch. We're very happy.
Yeah.
And of course, planetary defense is important, and so is international collaboration in this regard. And our office, the United Nations Office for Outer Space Affairs, works with member states, space agencies, and of course, European Space Agency is an important partner on strengthening collaboration also against asteroids, so that we are prepared, because an asteroid impact does not concern only one country, it concerns more, it can concern more space agencies, and that's why we need to bring actors together to prepare for successful missions in case there would be an impact threat.
Yes, obviously this planetary defence requires a really strong international collaboration. So how do you at the United Nations coordinate people like European Space Agency and some of the other space agencies?
Yes, well, member states already in the 1990s tasked the Committee on the Peaceful Uses of Outer Space to strengthen collaboration. And based on that, the committee established two global mechanisms. One is the International Asteroid Warning Network, or IOWAN, which is chaired by NASA. And the other one is Space Mission Planning Advisory Group, or SAMEPAGE in short, which is chaired by European Space Agency. And they collaborate. The IOWAN network would observes the skies and would inform the office in case there is a credible threat.
Yeah, so Richard, European Space Agency plays a key role in planetary defence. How is European Space Agency contributing to protecting the Earth from asteroids, I suppose, potential asteroid threats?
As was mentioned earlier, we are one of two agencies in the world which have all in one package, so to speak, a full planetary defense unit. We observe asteroids, we calculate their orbits up to 100 years in advance, and then if we find any threat within the next 100 years, we react to it and support international collaboration to mitigate any efforts. And in such a way we are doing a lot for the planetary defense community in carrying a part of the burden. Yeah,
so what are the sort of current projects that ESA's up to, and what are some of the ones that you're building towards?
Well, our biggest project so far just spectacularly got launched. But that's not where it stops. On the contrary, that's just the beginning. We have to close a lot of observational gaps, how we call it. The night sky needs to be scanned more often and more thoroughly, so we're building a full survey network of telescopes called the FlyEye network, where we scan the night sky every 2 nights completely. Also, we're launching a mission to the day side of Earth where we're completely blind. For example, Chelyabinsk, we couldn't have seen it coming. We are launching a dedicated space mission to spot things like these and many more.
Yeah, that was a great day. Well, where did that come from? Yeah. So one of the most talked about asteroids that we've heard about already is Apophis, that's coming round in 2029. What's so special and significant about that asteroid?
I mean, Apophis is significant because it's going to approach the Earth at a safe distance, but it's a very unique opportunity because it will be visible across the globe in many places with the naked eye. Actually, I have a model here, my stress ball. So at the United Nations, we're working with member states to declare 2029 as an International Year of Asteroids and Planetary Defense. And we will invite public, schools, universities to collaborate, space agencies, so stay tuned.
Wow, yeah. I mean, I like the fact that you should be getting stressed by asteroids approaching, but yours is doing quite the opposite.
Exactly.
You're taking your responsibilities very seriously, protecting the Earth. So thank you, Romana, for shedding light on the global efforts, and thank you very much, Richard, for sharing European Space Agency's absolutely pivotal role. So thank you both very much. So now let's turn our attention to another key mission that laid the groundwork for HERA, NASA's DART mission. HERA builds on that success of NASA's DART mission, which was the first ever test of asteroid deflection. While DART demonstrated that we can nudge an asteroid, HERA will now study the aftermath of that impact, providing crucial data on the effect it had on the asteroid. This will help us refine planetary defense strategies in the future. So let's take a closer look at DART and its groundbreaking mission, literally.
A year ago today, the world watched as the DART spacecraft smashed into moonlet asteroid Dimorphos with the goal of changing its orbit. This kinetic impactor test was NASA and the world's first planetary defense test. Our momentum didn't end with DART's collision. Here's what's happened in the last year. In the immediate moments after impact, telescopes from around the world captured a burst of bright light, and the Italian Space Agency's LICIACube made its flyby. DART scientists were looking for the amount of ejecta, the plume of debris generated by the impact that would give Dimorphos an extra push. Turns out, it was a lot, ultimately moving Dimorphos more than the spacecraft itself. When the math was done, the orbit change was a whopping 33 minutes. While analysis is ongoing, knowing this crucial number confirms that a kinetic impactor is a viable solution and will help scientists calculate how far in advance future missions may need to deploy. The ejecta tail would eventually stretch to over 70,000 kilometers long, about 10,000 tons of debris, and is still visible when last observed over 9 months post-impact. This ejected material are not on a course to be a threat to the Earth, but tracking them provides a better understanding of this unique test. The stunning images sent down by the Draco camera before impact have gotten a helpful lighting boost from the reflection off of Didymos, what the team is calling Diddy Shine. Modeling work using these images have allowed the team to build out the precise geography of Dimorphos, including the exact collision site. This work will be supplemented in 2024 when the European Space Agency HERA launches. HERA and its CubeSats will arrive in 2026 and land on the asteroid system in 2027 and provide radar imaging that can tell us more about the impact and about Dimorphos itself. The more we know about Dimorphos's specific traits and makeup, the better that scientists can extrapolate how kinetic impactors can affect other asteroids that we may one day discover heading our way. DART was the first ever planetary defense test for the world. The lessons learned in the days and months since impact have put us in a better position than ever before to defend ourselves from potential asteroid collisions.
So that was a great overview of the DART mission and its groundbreaking achievements. Someone at the forefront of planetary defense is Lindley Johnson, and he's head of planetary defense, no less, at NASA. He was unable to join us in person today, as he's probably going to be at the Cape for the launch, but he has prepared a special video for us, and it explains DART's heritage and how the European Space Agency with the HERA mission is building on that legacy to take planetary defense to the next level. So let's take a look.
Hello, this is Lindley Johnson from NASA's Planetary Defense Coordination Office. We want to give our congratulations to the European Space Agency and the HERA project for a launch of the HERA mission to the asteroid system Didymos and its moon Dimorphos. The collaboration that NASA has had with ESA for this effort that we call the Asteroid Impact Deflection Assessment, or AIDA, goes back for over a decade, when discussions were had in the planetary defense conferences and the Near-Earth Object Working Group under the United Nations Committee on Peaceful Uses of Outer Space, of how international space agencies could collaborate together to demonstrate a viable response to an asteroid impact threat should it be discovered. So that led to the establishment, under the United Nations endorsement, of the International Asteroid Warning Network and the Space Mission Planning and Advisory Group. And in parallel, this AIDA collaboration between NASA and ESA for an ongoing demonstration of the kinetic impactor technique to deflect an asteroid in space. So it was agreed that NASA would develop the kinetic impactor, which was the double asteroid redirection test, or DART, that impacted the moon of Dimorphos back in 2022. And since the kinetic impactor could only observe the asteroid for a few moments prior to its high-velocity impact, we needed the observation spacecraft that has become the ESA HERA project to do a more detailed characterization of the asteroid system, its composition and characteristics, and understanding the effects and a more detailed examination of the effects of the impactor on the moon Dimorphos. So that is what the HERA mission will provide in more detail for the demonstration of the kinetic impactor and this collaboration that we've had between NASA and ESA for all these many years. So the launch of HERA is certainly an important milestone for this endeavor, but it is really the beginning of the real work for the HERA project team for the 2 years of flight to the Didymos system, and then going in orbit and then collecting all of this data that is important for the HERA science team to add to our knowledge that was collected by the DART investigation team. So again, congratulations on launch and bon voyage, HERA.
So thank you so much, Lindley, for your time and for that really insightful look into the NASA and ESA collaboration. Now, I'm actually really excited about this. What's really exciting about the HERA mission is that we're not just talking about one spacecraft, it's actually carrying three. Well, there's three. It's carrying two. HERA is carrying 2 CubeSats on board, each with its own specific mission to gather even more detailed data from the asteroid. To tell us more about these incredible mini spacecraft, let's take a moment to explore the world of CubeSats. So joining me now is Filippo Corradino, the Chief Technology Officer of TIVAC International, the company behind one of these innovative CubeSats that are on board the HERA mission. Filippo, welcome to this little studio of ours.
Thank you.
So we've just heard there that there was this impact crater and the HERA mission is there to kind of investigate what's happened to that asteroid. So why CubeSats? Why do we need CubeSats to help?
Sure, well, CubeSats are very small, the size of a shoebox, and they can be released, these 2 CubeSats, by HERA, a few kilometers out from the asteroid. And their mission is to take more risks than HERA can by itself and get as close as possible to the asteroid and bring their instruments really where they can do the most. And in the end, actually even land on the asteroid, which would be a first for CubeSats ever.
Yeah, I mean, it's always great to have a first on a mission, and that's certainly a pretty cool one.
Pretty cool, yeah.
It's a very good one. So each of the CubeSats on board HERA has its own unique mission.
Yes.
So can you tell us a little bit about each one and what they're designed to do?
Yes. Well, Juventus will look more at the structure of the objects. So it's got this radar, and by listening to the pings and echoes of the radio waves passing through the asteroid can tell us whether it's a solid chunk of rock or if it's a rubble pile, so many different rocks just held together by gravity. And once landed, can also measure the surface gravity with another instrument. While Milani is more of a little chemist, let's say, it will look at the composition of the asteroid. So we've got a camera with visible light and infrared light sensors, and can tell us which minerals are on the surface, if there's water, how much of it. And we also have got a dust detector. We expect after the impact there will be a lot of dust in the environment, and we can measure how much of it is there, and what it's composed of.
Yeah, so the naming of the CubeSats. So at first glance you might think it's football related with Juventus and Milani. So, but I'm told that that's not the case.
No, it's just a coincidence, actually. So Juventus comes from mythology. It's the Roman name of one of the daughters of Hera, the goddess, while Milani is named after Professor Andrea Milani, who was the first astronomer who had this idea of the double mission with the spacecraft to impact on an asteroid to deflect it, and another one to go and run this crime scene investigation, check the aftermath, what's happened. and do the science.
Yeah, I mean, I really love the fact that it's Milani. It's such a fitting tribute to the man himself, whose idea that we're really kind of looking at. And I just love the fact that you're using CubeSats. It seems that CubeSats have sort of really opened up that space exploration to many more people and many more institutions.
Absolutely, yes. It's very, very nice, very interesting missions.
So yeah. So the mission is full of firsts. So can you tell us, is there any sort of new technologies or groundbreaking technologies that are on these CubeSats?
Well, sure. For instance, on Milani, we had to develop a new thruster to move around the system. So a cold gas thruster, which needed to be very tiny because they're small, so they're packed full of equipment. And so we had to develop from another existing one a smaller, more compact thruster, and it's got these little tiny jets, very, very tiny jets to move around, and many other innovations, navigation cameras, radios also, the link with the mothercraft, the intersatellite link. It's a new piece of equipment.
Yeah, so that was something we saw earlier on. Was that tested in that big room with the big
Yeah, that was the final test for the ISL, with all the spacecraft communicating with each other and with ground in that moment.
Yeah, were you there at STEC when that
I was not. A colleague of mine that was there, yes, but it was very exciting. It was remotely dated.
As an old acoustician, that's one of my favourite rooms I've ever been in.
It's huge.
It's such a good little space. So yeah, they talk to HERA and then HERA talks to Earth. Have I gotten that right?
Yes, absolutely, yes. Because you cannot feed the radios you need to communicate directly with Earth on these tiny boxes.
Yeah, I mean, it's brilliant. It's brilliant. CubeSats going out into deep space and landing on asteroids. You couldn't make it up. So thank you so much, Filippo, for joining me. It's fascinating insight into the role of CubeSats these days in missions like this. So it's incredible to see how much innovation is packed in. So now just a quick reminder why we're all here today. This is a major moment in planetary defence as ESA's HERA mission builds on the legacy of DART, taking us one step closer to understanding how to protect the Earth from asteroid threats. We're now checking out the SpaceX feed as the launch vehicle approaches its long coast phase. This is a critical part of the mission, with the vehicle cruising through space before the next major event. The team is closely monitoring everything as we move towards the next phase of HERA's journey. So now we've had a glimpse at the spacecraft progress, it's a great time to look ahead to the future of planetary defence. HERA is just really the beginning. The follow-up mission will be Ramses, and that will build on the knowledge that HERA gathers this time round and push the boundaries even further. So I'm really pleased to bring back Paolo Martino, lead system engineer for the HERA mission, who will share more about both HERA and what we can expect from the exciting Ramses mission. So welcome, Paolo, once again.
Thank you.
How's your emotions?
Luckily, I had some minutes to recover because it was really a very emotional moment. I just run out of tears. That's it.
You've run out of tears, right? That's fantastic. So what do you expect to be HERA's legacy, and how will Ramses build on that legacy?
In terms of planetary defense, HERA is just the beginning. We just come out of an outstanding fast development. We launched today even one day ahead of schedule, but that's the only way to meet asteroids. They don't wait for you.
No.
And now the next mission proposed to our member states in terms of planetary defense, the place to be in planetary defense is asteroid Apophis. In 2029, the night of Friday the 13th of April, we'll have a very close encounter with Earth. Actually, we'll be as close as roughly 30,000 kilometers, so we'll be even visible with naked eye from all Europe in that night. And it's so close that the gravity of the Earth is expected to have a strong effect on the asteroid. So on top of changing its orbit, will also change its rotation and possibly create material movings or landslides, earthquakes, really something unprecedented for an asteroid. It's really a great occasion to further improve our knowledge of these potentially dangerous objects. But the schedule is really, really challenging. We need to launch in April 2028, which is even faster than HERA. This is why we are working on this mission called the Ramses, Rapid Apophis Mission for Space Safety, which builds on the legacy of HERA and gets even more even faster, even more streamlined in order to basically be adapted to the different mission profile and manage to encounter the asteroid slight before its encounter with Earth and accompany it to this incredible moment.
So you've got your HERA team, and we've seen how much work, when you showed us the launch campaign, how much work to put that together, and of course the culmination of launch today, which is why you're very emotional. And you've been working late as well on the Ramses project. So how when you tell the team, we've got this new project and we've got to work even faster and harder, how does that go down?
The team is incredibly passionate and motivated. We all are. We really look forward to start prepare this new adventure and hopefully get the blessing at the end of next year. Most likely our families will not be as happy and motivated as we are, but I take the chance to thank all of them for their understanding.
Yeah, I mean, well, after all, you may be actually saving the planet. It's a good excuse. It's better than the excuse I have. So what have been really the